Okay, so before we get started, just a couple announcements. Oren and I are still working on your revisions that you've been making, either to that 2.5 analysis worksheet. I think almost every single one of you is done with that now. And also the Excel spreadsheet calculators. Almost all of you got that almost full points. There's a few of you that are still missing a few points on your accuracy, but overall I thought they were really good. And those of you that earned your full points and possibly the bonus did a pretty nice job of coding those. So if you have less than 20 points on that assignment, like if you have an 11 or a 12 or something like that, and you're happy with that, then so be it. But if you want to make improvements, you just need to do so and then let me know when you have the updated version in your spreadsheet. I've tried to give as much feedback as I can, like, hey, your mistake is in cell H10 or J10 or something like that. But if you feel like you didn't get enough feedback and you're a little bit stuck, I said this on Friday, just email me and say, can you look at mine again and give me a little bit of feedback, and I can do that. So I'm still going to give you probably the rest of this week to clean that up if you want, and then after this week, we'll just call it a done assignment. So, and then also your test that you took on Friday, the scores were quite good on the test. I was pretty pleased overall for the average for the class. I don't know what's going on there. Okay. You won't be able to see like which ones you got right and which ones you got wrong and whatnot until everybody has taken the test. And there's still a few students that haven't taken that test, but I'll let you know when that's available. And then you can go in the grade center and you can look that up. So, any comments or questions on any assignments or tests that we've done thus far before we move on? Going once, going twice. Okay, we're going to move on to Chapter 3. And I've said this before, but we only spent that Chapter 2 mostly on solving equations, right? Here's an equation, solve for x. Here's an equation, solve for x. The rest of this course is going to be based on functions and their graphs and their formulas and their behavior and all the problem solving that we can do with functions. That'll take us almost to the end of the course here. So, I know you guys are familiar with functions. You've heard it before. You've worked with it a little bit before, but we're going to just review some terminology and stuff to make sure we're all on the page. Here's kind of an ugly definition of a function. And this PowerPoint is available on Blackboard too, so you can always pull it up later if you want. A relation that matches each element of a first set to an element of the second set in such a way that no element in the first set is assigned to two different elements of the second set. That's kind of a mouthful of a definition, right? We have two sets, and we're taking the values of one set and we're matching them up with the values of another set. Okay? So, here's just a really quick activity that I'll demonstrate it. You got about 4 seconds to think of your favorite movie. Everybody got their favorite movie? Okay. So what our function is going to do is it's going to use the movie as the input. And then the rule that the function is going to do is it's going to produce the first letter of the title of the movie. So then the output would then be that letter. So for example, a lot of times when we do functions, you'll see like a little in and out box, right? This is the value that's going to go in. It goes into the function box, and then it spits out a value as an output. So my favorite movie is Back to the Future. And if you chose a movie other than Back to the Future, you're wrong, because Back to the Future is better than your favorite movie. Okay? What did I say the rule was going to do? It's going to pull the first letter of the title of the movie. So if Back to the Future is the input and it goes into the red function box, what's going to get spit out? B as in boy. Because Back to the Future starts with a B, right? Another one of my favorite movies, Mission Impossible. It's going to spit out a what? M. What's your favorite movie? What's your favorite movie?
Happy Gilmore.
Happy Gilmore. Ooh, very good. Happy Gilmore would spit out also one of my favorites. I actually had Billy Madison, another good one. What's Billy Madison going to spit out? B, right? So, is it possible for two different movies to start with the same letter? Of course it is. Back to the Future and Billy Madison, that's an example. I'm sure you can think of many other examples, right? So if we go back to our definition of a function, it said we're going to map every member of the first set with a member of the second set such that no member of the first set can be mapped to two different members of the second set. And this is where students get mixed up a lot of times. For example, Back to the Future produces a B. Is it possible for Back to the Future to produce anything other than B? No, it can't. But is it possible for two different movies to produce a B? Yes, it can. Okay? So this is where we'll start doing this with numbers and we'll get a little bit better sense of it. What happens if I asked you how many elements, if we listed them all, how many would there be in here? If we listed everybody's favorite movie, or if we just listed every movie, there'd be a lot of movies, right? However many movies there are. Do you guys agree it'd be a massive number? Okay. How many elements will be members of this set? Same as the number of movies? No. If we're talking the English alphabet, how many would there be? 26, right? 26 letters of the alphabet. So there should only be 26, A through Z in there. So what happens if, here's another one of my favorite movies. What happens if we entered that? Yeah, do we skip the 101 or do we say 101 starts with an O or it starts with a letter? Do you see where there's a little bit of a problem here? So we would have to be more specific on what we do and do not allow into our function, right? So sometimes you might say that since this function, we could define it as the only movies we're going to allow are the ones whose titles start with a letter from the English alphabet. And if that was our rule, then what would we have to say to 101 Dalmatians? We'd say we can't use you. You're not in that first set. You're not a member of that first set. You don't count because you don't start with a letter. Does that make sense? So let's talk some math terminology here. So we have an input and we have an output. So we usually call the first set the input. The more mathematical term is the domain. We call it the independent variable. And often we call that independent variable X. Now I got 4 bullets in the other blue cloud, and they're the opposite of the 4 bullets that I have up there. What do you think my first one is? Not input, but output. So the output goes in the second box. Not domain, but range. Very good. Domain and range. Those are mathematical terms. Not the independent variable, but the dependent variable. That's saying that variable depends on what we put in here. So the letter that got produced in the movie example, the letter depends on what movie you put in at the beginning, right? And not X, but Y. Or we use function notation. We often say f of x, g of x, h of x. That's function notation. So this should be terminology that you have heard of before. So we'll use these terms a lot. So we're going to talk about all kinds of ways to represent a function. We can do it verbally. We can do it numerically with a table of values or say a list of ordered pairs. We can do it visually by graphing it. And we can do it algebraically by coming up with a formula. The ones we're going to focus on are mostly number 3 and number 4. But there's 4 ways to go about doing this. Here's the 4 different ways, all on the same exact function. Verbally, I can just speak y is a function of x such that all y values are 3 more than twice each x value, where x can be any real number. Okay. Can you guys come up with the formula for that sentence? Y is a function of x. That means y depends on, y is the dependent variable. It depends on x. And how am I going to get each y value? Well, it's going to be 3 more than twice the value of x. What's 3 more than twice the value of x? 2x plus 3. So all of these things up here are the same thing. Verbal description, algebraic formula, y is 2x plus 3. I could make an input-output table, right? I could just start plugging in values of x and calculating the values of y. Like if I put in 0, for example. 0 is my input, my output would be 3. If I put in 1, I'd get 5. If I put in 10, I'd get 23. Just a plug and chug, right? Plug in the x, solve for y. And then, of course, the graph. There's the graph of a straight line. Notice that it has a slope of 2 and it has a y-intercept of 3. So that's the graph of y equals 2x plus 3. 4 different ways to state the exact same function, right? So we're going to practice some of these as we go. Here we go. Here's 4 bullets. See if you can decide which list of ordered pairs. By the way, this list, 1, 2, 2, 3, 3, 4, that would be like filling this in. 1, 2, 2, 3, 3, 4. So a list of ordered pairs is the same as filling in a table. How about that first bullet? We got to say yes or no. Does that represent a function? I see some yeses. Does it work? Yes, it does. How about bullet number 2? No, why not?
Because 1 equals 3 and 5.
Correct. Do you see how 1? You're saying an input of 1 gives me an output of 3, and then later on you're saying an input of 1 gives me an output of 5. But what did we say in the definition of a function? Each member of the first set, the domain, can only be mapped to one member of the range. So this is not a function. 1 can't go to both 3 and 5. That would be like saying a movie starts with 2 different first letters. We know that's impossible, right? So that one is definitely not a function. Notice 2 doesn't work either. Because 2 goes to 2 and 2 goes to 6. 2 can't go to 2 different places. That's not a function. It can be a relation, but not a function. How about the third bullet? I think it's no. Why not? Anybody see it? 2s and 3s are no good, right? 2 can't be both 5 and 7. 3 can't be both 6 and 8. Definitely not a function. How about the last one? Does that look like a function? Yep. That one works. Let's try something a little bit more like this. First set on the left, second set on the right. Function? Yeah, that one's not too bad. Each one goes to exactly 1. How about that one? No, 1 can't go to both 2 and 4. Not a function. Okay, let's look at the graph of a function. How about the one on the left? Is that a function? Absolutely. The one on the right? No, definitely not. Scan the x-axis with your eyes. Is there any value of x that produces 2 different values of y? Yeah, there's lots of them. So that one is a function. That one is not a function. So the question is, graphically speaking, how can you just look at a graph and determine if it's a function or not? There's a test for this. Some of you might be familiar with this. It's called the vertical line test. Yeah. If you can draw a vertical line, and that vertical line only hits the graph 1 time everywhere that you try to do it, if it only hits the graph 1 time, that means each value of x only has 1 output. So we're good. That's a function. But if you ever cut the graph more than once, then you have an x value that has more than 1 y value. That would not be a function. So that's the vertical line test. So if you apply the vertical line test to these 4, you should be able to visualize which ones are functions and which ones are not. What do you think of this guy? Function? Yep. How about that guy? Nope. Nope. And the other one? Would be a yes. So the 2 that fail the vertical line test would be those two, and then our other two actually pass the vertical line test, so they would be functions, right? Okay. Here's some formulas. X plus 3, is that a function? Definitely. X squared minus 4. Notice 2 produces 0 and negative 2 produces 0. Is that a problem? Can I have 2 different inputs give me the same output? This is where students get confused a lot of times. That's okay, isn't it? It's just like saying 2 different movies start with B. Back to the Future and Billy Madison, we can do that, right? So, can 2 give us 0 and negative 2 give us 0? Yes. That's definitely a function. How about the last one? Can 4 give us both plus 2 and negative 2? No. Not a function. Not a function. Okay? We'll get some more practice graphing these in a little bit. But let's do something a little bit more fun. I want you to go to Blackboard. Go to Course Docs and Links. I took all the Chapter 2 stuff and I put it at the bottom of the page. So just to unclutter my page. If you want to go back to the Chapter 2 stuff, you got to scroll all the way down to the bottom, and there's all that Chapter 2 stuff that we did. All those links, all those activities, the 2.6, 2.7, it's at the bottom. So now at the very top of your page is Chapter 3. That's where we're going to start. Here's the PowerPoint that I just went over, so you can take a look at that later if you want. We're going to do these activities from a website called Desmos. Anybody heard of that before? Maybe you tried some of this, and if you're a high school math teacher, there's a lot of fun activities on there. So what I want you to do is we're going to do Function Carnival Part 1 and Part 2, and I don't think we'll get both of them done in class today. So your assignment is going to be to finish both Parts 1 and Part 2. Hopefully we can at least get Part 1 done today, and then Part 2 will be like your homework assignment, okay? So it says go to this link, and you're going to click Join. What I'd want you to do now is there a place for you to create an account? If you already have an account, then go ahead and use it. The reason I'd like you to probably create an account here is there's going to be a time where you're going to want to sit down and work on a Desmos activity, and we're going to do a lot of them between now and the end of the semester. There's going to be a time where you want to sit down and work on one, and then you're just going to want to save and come back later instead of doing it all in one big sitting. And if you don't have an account, you can't save and come back. Does that make sense? So when you click Join, see it's already saying Welcome Back, Jamie, because I'm already logged in. Did you guys find where you can have it, where you can create your own account? You just got to give yourself a username. I think, does it ask for an email? And like a password maybe? Is that right? Anybody having issues? Or are you able to create an account? Once you are in and you've created an account, when you click Join, I'm not going to click Join because then it'll show up as a student. So what I'm going to do, there's a teacher view and a student view. You guys are only going to have the student view, so you're not going to see what's up on my screen. Only I get to see what's on my screen. So Function Carnival, right now, it looks like 17 of you are in there. But there are 5, 6, 7, 8, 9, 10, 13, 16, 17, 23. Oren, are you in here?
Yep, I am.
So there should be 24 total. See how I can see all your names off to the side here? What I'd like you to do is it starts with Canon Man. I got to look at one of your guys' computers. Who's ready and logged in? It says it starts with Canon Man. So what I want you to do is hit the little play button and watch Canon Man. Your goal is to graph what you see happening there. Notice that the x-axis is time The independent variable is time, and the y-axis, or the dependent variable, is the height of Cannon Man, his height. So I want you to try to sketch the graph, Cannon Man's height as a function of time. Now, if you're really getting kind of clever here, you can either try to sketch it all at once, or what you can do is you can push play and then pause it and put a dot there, and then pause it and put a dot there, and then pause it and put a dot there. You see what I'm getting at? And then just play connect the dots when you're done. Anybody having any issues with it? Do you have your computer today?
It's dead.
It's dead?
So
Okay.
I was gonna do it
Just
after.
yeah, share along for today. So far, my computer is telling me that out of 23 of you, one of you is precise. If you look at my screen, you can see what everybody else's looks like. See how I can see all of them at once? I see some of you are starting to plot some points. Try that strategy. Hit play, watch Cannon Man go for like a split second. Hit pause, plot a point, play, pause, plot another point. Plot like maybe 4, 5, 6, 7 points, and then connect the dots. That looks good. Time is the x-axis. Height is the y-axis. Comments or questions on that graph? Have you guys been able to look at the exact answer yet? I can't remember if you guys get to see that on your end. You can only see your own, right? Can you see any of your classmates? You can just see your own? So what you should have ended up with, if you can see the dark one on my screen, the dark green one, it should have been kind of like a parabola arch as he's going up and reaches the top, and then as he's going down, and then where is it going to change? Where he gets his parachute, right? Because what happens when he gets his parachute? Then it's just a steady straight line. So see how here he is on his way up. Here's where he reaches the top. Now he starts falling, and then right there, parachute comes out, and he glides on a straight path to the ground, right? So it looks like almost every one of you has got a pretty good graph going on there. So when you're happy with that one, go ahead and move to the bumper cars. I think that's the next one, right? Now, as you watch that, I want you to think about what we're actually graphing. What are the two variables if I had to label my x-axis for the bumper cars and my y-axis for the bumper cars? Let's all agree before we start drawing any graphs. Let's agree what two variables we're interested in. What do you think our independent variable is? Time. Yeah, let's do time again, right? So time will be the same, but we're not going to do height off the ground like we did for Cannon Man. What do you want to do for our vertical axis? I'm going to have you do sorry, wait a second. Yeah, I'm going to have us do total distance driven. Total distance driven. So like imagine that the car has an odometer and it's just keeping track of the miles. Does that make sense? So I want you to try to do that. I'm sorry, I had you guys skip over part 2. You were supposed to help some student named Eric to help him fix his graph. Is that correct? Is that what the second part was? So when you get done with that, then you can go to the bumper car. It looks like only 6 of you helped Eric so far in step 2. This one, the teacher center is different on this one than what I'm used to. So you're on step 3, right? Just go back for me. Humor me once and go back one. Oh yeah. Okay, go back. That's the one. And now it's asking you to type and help.
It just didn't show me that right away.
Oh, yeah. We can kind of do this one together. What's wrong with Eric's graph on step 2?
He doesn't account for when the parachute opens.
Yeah, he doesn't account for when the parachute opens, right? Do you see how his descent is just a straight line? The other thing that would help Eric, do you see how his is kind of like a point, like this? But what did we know about how it really happened? It was more of a curve, like a parabola. So that might help Eric with his graph a little bit too. Okay, that's fine. We're done with Eric. Go ahead and work on the bumper cars. Don't let the curly little drive confuse you. We're only measuring the total distance that the car drives. We don't care if he's going left, right, up, or down. We're only measuring the distance that the car drives. So again, if you look up at my screen, you can see that a lot of people's are starting to look the same. back here?
I have to start mine.
Oh, okay.
'Cause I-
So a lot of yours are starting to look the same. I just put my answer on there. Somebody explain to me why it's just flat at this point. What's going on there? Yeah, there's the crash, meaning that the car stopped moving, but time is still going, right? So for those last few seconds, time is still moving, but the car's not moving at all. Therefore, we have a flat line at the end, right? Now you're going to see Jenny's graph. It says, what does her graph say will happen to the bumper car? How would you help her fix it? And when you're done with that, if you're kind of ahead of everybody else, you can go on. The last one is a Ferris wheel. So if you already helped Jenny, go ahead and move on to the last one. Does anybody have a picture of Jenny's graph on their screen right now? That's what Jenny drew? Okay, very good. Thanks. When you look at Jenny's graph, I drew something similar to Jenny's graph up here. Is Jenny's graph representing a function? If you applied the vertical line test to Jenny's graph, would it pass or fail? It would fail. Jenny's not using the appropriate label, right? She might be saying time here, but she's definitely not doing distance traveled. She's doing like position on the screen or something goofy like that. So what Jenny would be saying then is at this time, whatever time this is, it doesn't matter, that the car is here and here and here. That fails the vertical line test. A car can't be in 3 different places at the same time. It can't even be in 2 different places at the same time. Does that make sense? That's why Jenny's is not a function, whereas if we were just measuring time and distance traveled, that would be a function. Because when we do it that way, we don't have our car in 2 different places at the same time. Does that make sense? Go ahead and try your Ferris wheel. Does anybody have Sophia's or Sophie's graph on their screen for the Ferris wheel? I want to look at it. This one's not as user-friendly for the teacher view. That's what Sophia drew. Okay, very good. Thanks. Good. Very precise. Nice. You can see from my screen that many of you are charting the exact same thing here. What's wrong with Sophia's?
Too angry.
It's too sharp, right? The car doesn't get to the top and then go straight back down. It's more of a smooth curve. And some of you even drop the word sine or cosine in your definition. So some of you have a little trigonometry experience. But that is just a repeating wave function, right? It's just going to keep going like this over and over and over again for as many times as the Ferris wheel goes around. So is that a function? What you're drawing right now and what Sophia had on there, is it a function? Yes. Does it pass the vertical line test? Yes. Now notice if we did something called the horizontal line test, I can go up here and I can say vertical line test. It passes, right? Nowhere do I ever cut the graph more than once. So we can say, yes, it's a function. However, what happens if I tried to do a horizontal line test? Would it pass that? Do you see where it would fail that? Now, horizontal line test isn't testing to see if it's a function or not. That's what the vertical line test is for. Do I have any x values that produce more than one y value? We already said no, so it's a function, right? What am I actually testing if I do a horizontal line? Because a horizontal line cuts right there and right there. Anybody, can you explain what I'm testing for there? We already said it's a function. There's another descriptor that we can give to a function. Sometimes functions are what we call one-to-one. A one-to-one function. What that means is every single output only comes from exactly one input. Okay, so our movie example would not be one-to-one because there's two movies that start with the letter B, right? It's a function, it's just not one-to-one. This wave function on the Ferris wheel is a function. Is it one-to-one? No. Why is it not one-to-one? Because there's multiple times where it reached the same height. Do you guys agree? Whatever time this was, I was at this height, and then a few seconds later, I was back at that same height again. Right? So still a function, just not a one-to-one function. We'll get some more practice with that in the next one that we do here. Comments or questions before we close out of this one? Okay. What I want you to do then is go back to Blackboard, and there's Function Carnival Part 2. Function Carnival Part 2. Same thing now, if you're logged in, it should just say welcome back with your name. Does that work for you guys? And then just go ahead and click join. You're going to see it starts out with our Cannon Man again. So step number 1 is just a reminder of what Cannon Man did. So I want you to go through the first few steps of Cannon Man and answer the questions that come with each of them. So I made this anonymous, so you can't see names, but I did put one up on the screen for number 3. This student said Cannon Man was at a height of 5 feet at 12.3 seconds. Is that true? What did this student do wrong? They got the variables mixed up, right? Cannon Man was actually at a height of 12.3 at a time of 5 seconds. You see how this one got switched around? So if that one was yours, you can go back and fix it. Here's another comment. I have a slight problem with this one. Somebody want to read my brain?
He was going, at the beginning, he was at 12.2.
Correct. So this makes it sound like it took all the way up until 5 seconds before he reached 12.3 feet. But actually he reached 12.3 feet one time earlier, did he not? On the way up he reached 12.3. And then at 5 seconds on the way down, he also reached 12.3. So when you say it took 5 seconds to reach 12.3, he's already been to 12.3 once, right? So it's not that this is inaccurate, it's just precision, right? I think that's just not quite worded the way that I would have worded it. This is one that I like right here. At 5 seconds and 12.3 feet, tell us that the speed he is flying changes. Do you guys agree that it changed at that point? So a lot of you said at 5 seconds the height was 12.3. Correct. But then there's one more important thing that happened at that point. His speed changes, something slows it down, and it becomes more gradual, like his parachute. Right? So whoever wrote that seems to know what's going on here. Now, when you get to step 8, and only one of you is past there right now, when you get to step 8, there's a bunch of cards, and you're supposed to put them together in groups of 3. So when you put them together, if you can't figure this out, one of them is going to be a graph. Remember how we said there's 4 different ways to do this? Verbally, a graph, a function, and a table. Well, we're doing 3 of them. You're going to see a verbal card with a sentence. You're going to see a graph with a picture. And then you're going to see function notation, like f of something equals something. Okay? You got to put the 3 together that match. And when you put 3 together, You just hover over. Let's say I think this one goes with this one, goes with this one. See how I hovered over? And now I made a set of 3. They will lock in if you hover them over each other. Does that make sense? That's your goal on step 8. It's a little matching game. So we've got about 2 minutes left of class time. So I am giving you a grade for completing these. Some of you might finish this one in class. Some of you might not. But Carnival number 2, the one you're working on right now, that'll be due by class time Wednesday. And most of you are far enough along where you don't really have very much left. So that's really your only assignment that's due on Wednesday. 3.1, just like always, I've done it before, there's practice homework out of the textbook. And eventually, when you're ready, you can take the 3.1 quiz. Now, I'm going to say this again. I said this last time and on the first day of class and everything. All of those quizzes, OpenStax 3.1, 3.2, 3.3, 3.4, you take them. If you don't like your grade, do what? Take it again. I was actually a little bit surprised of how many of you got like 2 out of 5 or 3 out of 5 on those quizzes and chose not to take them again. I'm giving you the opportunity to take them again so you can practice and then you can get your full points. And then the other rule I gave you is that when we sit down to do the test for that chapter, all of those quizzes needed to be done, right? So you were supposed to have them all done by Friday before you came here, and there was a handful of you that never did 2.7 or 2.6 or 2.5. So again, you get multiple opportunities to do these quizzes, but you got to have them all done. The reason I give you multiple opportunities is so you can practice and practice and practice, and hopefully that'll help you get ready for the test. So we're going to do 3.2 on Wednesday. Finish this. Take your 3.1 quiz if you're ready, and we'll see you Wednesday.